Now let's come and discuss clouds in a little more detail. This slide here is also from Gartner. We had a Gartner type technology side already. This is a so-called priority matrix, and they plot benefit, which they do transformational, high or moderate versus time scale. And if we look at cloud computing, and this is a mosaic of 5 years from 2008 to 2012, we see that cloud computing is present in every year in the 2 to 5 year time frame transformational category. And then we look here, we can see in 2012 and 2011, big data has joined cloud computing as being transformational and modest, relatively near term. And so the combination of clouds and big data is really a disruptive transformational technology group area. Comment on clouds that Amazon is making a lot of money. They had $650 million in revenue in 2010 and a revenue of around 3.8 billion in 2013. And this is the first public cloud computing supplier. There are, of course, many other clouds now available, including those from Microsoft and Google and other smaller organizations. And these all build on the technologies designed to run Amazon, Google, Bing, and eBay. But it's still interesting that Amazon is actually making money from web services, and whereas most IT organizations cost money, for Amazon, if you sum what they pay to run the Amazon IT service, and then you subtract, I guess, the dollars they get from selling services on the Amazon cloud, Amazon has an IT organization that makes money for the company. So that's good. Directly makes money. Because all IT organizations hopefully indirectly make money because they're supporting the company. So what are clouds? They're a set of computers in an efficient data center with an excellent internet connection. They were produced originally to satisfy public-facing so-called Web 2.0 social networking e-commerce sites like Facebook, Amazon, search engines. And you can view clouds as the optimal giant data center because they were designed to be very efficient, to scale to enormous size, because if you have enormous size, you better make your system efficient because it's just relatively small gains in operating efficiency makes a lot of difference to the cost of your data center. And clouds can either be public, as in Amazon, or private when you actually take the same technology, and instead of building a public data center where you sell time on it to the public, you just run it for your own enterprise, and that's a so-called private cloud. Here's a slide from Microsoft pointing out they have around 100 globally distributed data centers. They vary in size from 100,000 to 1 million servers at the largest end. That's the so-called mega scale. And here's some pictures of the warehouses that hold their bigger data centers. Here's one here, they're so-called fourth generation. That knows that maybe we don't even need to put our servers inside a building because clouds are huge, clouds are designed to be fault tolerant, and so it may be better to actually run in a very much cheaper, more environmentally friendly environment and not optimize everything from each individual machine for 99.999% uptime. You optimize the efficiency of you optimize the system for that uptime, but not individual machines. And so clouds automatically build in fault tolerance mechanisms, and because you have such excellent fault tolerance, you can afford to make any individual component of the cloud less fault tolerant, which means you can actually save on operating costs, which we pointed out is pretty important. A lot of these systems are built around shipping crates, shipping containers as the basic unit, each with some 1,000 servers in them. Here's a picture of this so-called fourth generation data center, which is this is a larger version here of the smaller version over there. Here's some more comments from Microsoft of pointing out the size here. A data center can be many times the size of a football field. And if you look at the cost improvement of a data center, because of the economies of scale, you can save money. And we typically in the ratio for storage, network, and administration, they vary from factors of 5, almost 6, 5.7 to 7. Here's a prettier picture with nice mountains in the background of a Google data center on the Columbia River, which presumably gets relatively cheap power from hydroelectricity. It happens that clouds use something called virtualization, which basically is pretty helpful for clouds, because clouds, you don't actually know where your job is run. So the concept of virtualization, which is to abstract where you run and just take all that chore of knowing exactly where you run away from the user, is pretty important. It uses technologies called hypervisors, which support so-called images, which make this virtualization particularly convenient and efficiency. And then allows you to think of the job as not just your application, but the application plus the operating system. And that thing is called an appliance or an image. And because you view that as the unit, you can actually move those applications around much more easily, because usually people have trouble moving applications because you're moving from one operating system to another, and then your application rarely runs on a different operating system. So using images or appliances is very important. And also this virtualization model somewhat improves the security model, because you can encapsulate things if it's a complete running operating system. Whereas if the same operating system runs multiple applications, it's relatively difficult to make it intrinsically secure. Here's an example of advantages of so-called consolidation, which is using this idea of virtualization to move a large set of machines, which typically run at less than 100% efficiency, and you move that to a so-called server consolidated environment where multiple images run on the same machine. Then they noted in this example here 60% saving from here $16 million operating cost when they did the 6-to-1 consolidation. Here's an example from Google about running email systems. Over here it's actually focusing on power, not in dollars. And if you look at the annual energy used per user in Gmail, that's less than 2 kilowatt hours per annual use, but for some much less efficient small business operation, it's around 100 times bigger. Here's this power usage efficiency. It's an important number, which is a measure of the ratio of the power used by your center to the power used by the computers in your center. You can see a traditional small operation has a number like that, 2.5, which says 1.5 of that in some sense is wasted. It is supplying the cooling and other things like that, whereas Gmail has a power usage effectiveness of only a little 16% above 1. 1, of course, is presumably the best value you can get, showing that clouds really have developed very efficient uses of computers. Here's a set of features which were identified by NIST, which has a big cloud computing initiative. to specify what clouds are for the government. Clouds have on-demand service. That's the so-called elastic property, that if you want 100 computers, you get 100 computers. You don't have to buy them. They're sitting there waiting to be powered on for your use. They have very good network access. Those resources are pooled and shared. You have a very flexible way of allocating um, resources, and everything is measured. You pay for your use. And this gives you economies of scale in performance and power. We mentioned electrical power a couple of times in the recent slides. There's also powerful new software models, so-called platform as a service, which is added to infrastructure as a service. We'll mention this a little later on. And the clouds have actually produced very significant software innovations, so-called, like things like MapReduce, NoSQL, data storage, and things like that. If you have a cluster, that cluster, if it's 100% utilized, runs flat out, doesn't waste too much money on power, on unnecessary power, that is actually pretty cheap. But clouds have the advantage that if you have erratic use, you only pay for what you want. And therefore, for many people, clouds are an attractive way of going. Here is a comment on by these various types of cloud usage: infrastructure as a service, which is the basic hardware; platform as a service, which is the system services like database and MapReduce; software as a service, which are the actual applications such as clustering or recommender systems or just billing; and business process as a service, which is the application set that run business processes. And this particular graph here from Gartner looks at the compound annual growth from 2011 to 2016, showing that infrastructure as a service is almost 42%. And actually, what's most important, software as a service, because that's actually the ultimate goal, that is somewhat slower, but still 70% per year. And here is the actual revenue associated with them. And of course, infrastructure as a service is a growing fraction of the software as a service.